All right, good afternoon, ladies and gentlemen. Something popped up and disorganized my greetings, but I think we are here. I know we have taken some time without interacting, without sharing. So I just came across something that I did. I did sometime a review of a bridge. There is somewhere along Muyembe and Kapire Bridge. It's called Chikunya Bridge in Sibet sub-region there in eastern Uganda. We were more interested in checking the stability of the foundation, the suitability. The consultant had proposed use of cyclopene foundation improvement. I think it's a special improvement they do, which is slightly an enhanced kind of stuff, more better than rock fill, the normal rock fill. The cyclopene or rubber concrete has, I think, bearing capacity range between 700 to 1000 if it is well done. While our normal rock fill, because of voids and you don't have proper control in the degree of compaction, could be limited to about 400, 500 there. But it's very good for managing groundwater trends, controlling the infiltration rates, and then also reducing the effect of buoyancy to our foundation or substructure. So this is a 3-span. It's a good design. I do appreciate consultants do a lot. It's a 3-span, and instead of having pier column or pier wall and solid one, I think they decided to go with individual columns. I think the only problem I see with this kind of columns or pier columns, especially when you are in water and fast running water, it will not take so long. You will definitely realize that the columns are experiencing high rate of scoring and will expose reinforcement within 20 years or even 30. If a bridge is designed for 100 years, you will not reach that. So there is need for special attention. If you want to go for this, of course, you have to check for impact. If it is if this is a river bridge where you have sometimes tree branches or tree stems flowing, or rock, especially if you're in the western Uganda and south, that is Kasese, where we have rock moving together with water, you are going to have to consider the impact from moving rock, those boulders. So definitely, columns are not like walls and slabs. Columns behave like also beams. If there is any defect at a particular section because of localized effect and concentrated loading, it will definitely get into a bit of unstable condition and can nap or buckle or can fail. So I think this is also good for road bridges, elevated, with also protection from impact from traffic. So I know many designers are going into this, and it is about cost. But now where the world is going, we are going back to the conservative designs, and cost is going to be second, because we are looking at retrofitting mechanism. When the bridge requires retrofitting to enhance its lifespan, there are always a bit of no redundancy. You are looking at economy. When you look at the size of this column, is more of economy, not actual robustness for safety. If you have water, definitely this one will not stand for so long. So I think comments were given, and consultant made some adjustment, I think, to improve on the longevity and exposure to constant high velocity water with a bit of turbulence, and also existence of foreign materials that can cause a bit of impact on the columns. So this project, I think, is basically all these bridges are done. We shall get some time, take some photos, compare, and then we'll appreciate. This is the design. Of course, as a designer, when you are going to check the stability, you also need to have access to the design from the consultant, because that's what you are reviewing. You model, just check. It's always good to do your spot checks or independent check. It's not a problem. It's a bit good condition, because normally if you go and read someone's report verbatim, and then sometimes it's subjective, because the engineers in the industry have different approach and mechanism, and yet the final product will not fail, it will work. So sometimes for me personally, I normally, if I get time, I do an independent check, so that once my independent check in a way agrees with yours, irrespective of the assumptions and other thing you have done, I have no reason for denying you progressing your design to implementation. But if there is a bit of disagreement, that's where now we also try to compare. So you get you get this. You can see this is the abutment, and then it has, this is now the rubber concrete or the cyclopene, about 3 meters. And then of course it is, now you can ask, we have 2 types of foundation. You have the spread footing. I think this improves spread footing. Then you also have piling. Someone will say, why don't you use pile? So it's the choice. Normally most engineers do take, and also contractor, and sometimes the employer's representative. And as I told you, normally people these days move to cost, money, forgetting that I think a project which is supposed to be for generations and generations, safety first, then you see how to look at the cost. But I think the trend is changing, because the International Bridge Technical Committee, and then the Road Association team, they are now working on ways of coming back with our redundancy consideration, and then robustness, diversity consideration, and other things. So I think that is a work in progress, and we hope that in future we shall be having projects that will, when it is designed and constructed, you can stay rest assured that it will work for generation and generation. So this is the design. Looking at it now, what next is, after having the design, you have your model, you have the design, you also need to have access to geotechnical information. Of course, this is now from the structural perspective. As a bridge engineer, you also need, you work with all these guys. You work with the hydrologist, you work with the surveyor, you work with the road guy, because the profile, the geometry of the bridge must be exactly verbatim the road profile, the road geometry laterally or the layout, the super elevation, the slopes, all that must depict the road, because a bridge is just a road. Just only that's the structural component of the road that requires the structural competency. That's where we come in. So you look at all these SPTN values, interpreted stuff, the original, this OGL is basically the river bed. Then now you take this bridge about 10 meters high. So you come down here, you find what I saw physically suitable or feasible is that for you to do good enhancement of foundation, if you don't want to go to piling, look at the bearing capacity of at least consistency from 50 onward, when it is moving now linearly and increasing in stiffness, the bearing capacity increasing. Then you are able to know that from this point, when I use the rock or any foreign material to stabilize and enhance the foundation, that material, when it forms a wedge, should not be able to begin settling. Since we control our settlement to about 2025, it means that if this wedge you are feeling down here moves also by about almost 50 or 100, it can cause distortion at the bridge deck. And that definitely, if it is a post-tensioning or pre-stressing concrete, this will be a problem. Even for reinforced concrete and others, if it is distorted and start moving, that is significant displacement. So when you have a bearing capacity of about 75, 80 and the rest, you are able now to remove that weak material or overburden material, and then you start laying. If it is the normal rock, you lay the normal rock. If it is this rubber concrete, you still do it in layers, properly with proper control, taking care of score depth and other things. So you need to have that. So basically, we had to get access to geotechnical information. So the observation here was that the abutment height from reduced level differ from what was on the drawing. The consultant contractor should check and harmonize and guide on review. Basically, I think there was some controversy or anomaly in the dimension, but basically those are some of the things that you can easily look at. Now, this is the abutment area. So this is the pier. So you know there are two pier support system. So here also. Now under the pier, you find they've done or near or close to the pier support. They have carried out the geotechnical investigation, bore logging, and you can see that at the face value up here, SPTN is 9, 26, 42, 98, 90, 95. So this is the most stable area. Actually, these are not SPT is 9, but the RQD. RQD is always 26, 48. Normally for better stability and soundness of bearing strata or rock, the RQD should be at least 75. So now you can see that there's this line here which I drew here is the line of the safe line with better bearing capacity. So it means now whatever improvement that the contractor and consultant needed, you must now, this is your new excavation line for you to cut and bring in the foreign material or the cyclopene or rock fill, stabilize it properly, taking note of the score depth and the flow under the bridge. Then you are able to do that. But above that would be more loose, or else they would have actually gone in for piling. And then you do piling and you forget. So they went in for slightly. They could say it was cheaper, but at the end we told you may find it's not easily cheap. So basically, so now the abutment and the 3-meter concrete wedge bear on weak layer SPT 14 approximately 100 kPa. This means the contractor should remove the weak layer and replace with damp rock together with the 3-meter concrete wedge. Now this concrete wedge is that cyclopene concrete or the rubber concrete they were talking about. That was already determined by the consultant. So we tried to create it, and we needed some explanation, which they did very, very well. They're very experienced guys, and they know what they're doing. So on observation on the pier basis revealed sound location as marked by the solid line bearing the description. This solid line with the description. This implies that the contractor must remove the weak layers to where RQD is 98.5%. is rich and fill with damp or good rock to provide stable bearing strata. Then from there they can do now their normal rubber concrete or whatever improvement is required. So it's not purely structure. You also need to have some clue on how to work with these guys to understand that your structure and in a way is safe. Normally the worry is this support which are in the middle of the riverbank, in the channelized water area. The kind of flow we assume for design and we use for modeling and simulating is computerized. But when you go on site and you witness what happened, Even disruption from the grass and tree branches alone will escalate the limits outside your envelope for design. So normally it is very important. I always make jokes to my youngsters that I'm an engineer's mathematics. If you are doing addition, 1 plus 1 is not 2, it's a 2.5. If your fear factor is slightly high, it's 3. Unless otherwise queried, then you can reconsider. So these are things that when you're here, when you do your computer design, please stop and have a bit of coffee and try to think through really, is it worth it? Is it going to be 10 years, 4 years? What will happen with the score? And then the kind of uncertainty in monitoring or in experiencing the flow regime in rivers. So I think so as we do this foundation stability, I think traditionally, if you looked at most of the Western bridges, we do appreciate and admire. They don't go in for that unless you have rock. If you have rock and you anchor it properly, design your SIA key and everything, anchor your thing, and that's it. That's okay. Spread footings are suitable for where you have rock foundation. I think it should be just that. The rest should be piling. Then we run and say cost, okay. But that is what we need to know. So this is a bit of a model. This is the model of this. This is the model. This is the drawing. Of course, it will not be exactly that, but if you want to spend some time, you can still do that. So this is now the model that was done. A model and then loading. And then these are some of the output. Load case generating, worst case soil pressure. That's it, 270. That is 274 kPa, and vibration mode 15 with a period off. I think it was supposed to die. I think it disappeared. So this is the vibration mode. I think I just combined. Okay, fine. Try to subject it to earthquake things, but basically most of buried structures and structures are at the same level with the ground normally. From our theory, and even when you try to check, it's not too much sensitive. But of course, it can create a bit of distortion and displacement laterally, and then the bearings can also move, if it is elastomeric or rubber, where the movement may exceed what the designer has done, and also the entire deck system can move. That is why we normally emphasize that you have the reaction block on the pier support system and also the bearing area to restrain the bridge from moving perpendicular to the road or laterally. You know, if there is a block from tree branch, it is going to create the entire opening will be like causing 100% resistance to the stream flow current, and definitely the bridge can also move. It can be lifted up because of buoyancy. When it is now moving forward, buoyancy, there's a push and also lift. So in a way also we need to lock the bridge. So long as it simulates exactly the support condition, we need to make sure there is a fixity at the support to some extent, so that we don't allow this lift and then you see your deck flowing like basin. So this is bearing capacity, applied soil pressure. Then you need to know your bearing capacity. Now, if you have used the cyclopene or rubber concrete with bearing capacity enhancement of between 700 to 1000, and now applied soil pressure, you are getting it at only 275, then your worry is sorted. Now the next is the stability, the extent of that, so that water does not score somewhere and the whole way tilts. So you start looking at the whole project now, from a bigger perspective. Don't just insert your stable structure in a small area when 2 meters away, when the thing creates another channel deeper than that, then the whole thing can also slide in people who do slope stability will know. So there's a lot of engineering techniques you bring in, not what you're studying in the class. Sometimes it has to be like something you have to be like a maintenance technician. You have to be like a contractor as a technician. You have to be like the consultant's assistant, so that you are able to see those nitty-gritty areas. Otherwise, if you remain as a designer always, you may not be able to see. That's why also it's good to go to side, B to side, and see some of the things. So this is the abutment footing plan model. This is, I think, this is the moment area, as you can see, concentrated areas under the foundation, under the abutment, and then spreading out. So sometimes also it also guides us on how the pattern. If you look at the contour pattern, we always just go and say, okay, Y25 at 150 everywhere. Fine, that's fine. But that is when you don't have the time. If you have the time, you can still zone your reinforcement in a pattern that will be cost effective and robust enough to give the desired functionality or response of the structure. So this blue area, you see now, this is the moment here is only 154 kilonewton meter per meter. This is 274. This is the area. So you can look at the pattern, the contour pattern, and you spend some time so that we are able to come up with. There's a lot to be done. Once the software gives you the outputs, now you can actually you can run with Midas. You can actually pick each of these can give you reinforcement. So from the area, from the reinforcement moments, you can now get actual area and zone it up again, and then you come up with what is good. So some time need to be spent. This is now this is a deformation. No, this is the moment. This is this is the moment, both foundation and what? No, this is a deformation. Yeah, so this deformation is basically about 11 millimeters. If you look at it from somewhere down here, so these are the edge here. We expect deformation. Remember, for your abutment, there is you see abutment behave different from the cantilever retaining wall. Abutment has extra vertical load from the deck load system, so that affect the foundation sizing and also response to the load. And then at the same time, you are having the lateral effect. The lateral effect from the approach embankment, the live load surcharge, dead load surcharge, if it is there. You have the pressure from soil that backfill. Then you also have the hydrostatic effect, and then also you have basically that. So the deformation pattern also matter. You can see that really it's basically the way the stress generation, the stress is generated. So edges, if it now moves too much the other side, it can start pushing more, and you see a tilt on the side with more rate, and you can actually check the value here. So basically, this also helps you to appreciate that normally we do design of abutment and foundation using linear meters approach, and yet globally the way structure responds is more in a contour kind of effect kind of. It's radio kind of, whereby you're going to see in the next slide. We don't just concentrate the load all the way up, down, from up to down. You need to know laterally there's something happening. Sometimes you'll find that reinforcement that move laterally here tend to be more, especially this kind of of the U-type wing wall. It's not the vertical kind of per se. You have to be very, very careful that it tends to move, because this area is fixed here. At the bottom here, it is fixed on the base, and then here also fixed. So in a way, you have free edge here, and cantilever, and so the failure pattern here is very, very interesting. You can even see what's happening here, the deformation mode, how the contour tend to move in this area, that one, concentration here, and somewhere here. So basically that is what we need. Deformation under the footing is there. Then some observation I think came for the bearing up, that at SPT 14 you have bearing capacity at 100, stability is weak in bearing and failed. So I think that was a check. Then there is also need to improve the footing at this point for bearing capacity equal or greater than 400. What does that mean? If you insist to remain at 100, it means you may end up with a bigger, wider footing. That they're moving to the rough kind of scenario. So there are areas to touch and then see what needs to be done. So this is now the moment, I think, pattern, and this is how you can see it. So if you just pick a linear meter, they're not the same everywhere. Look, and something that you need to know, this red corner here normally for wing wall, wing walls do have problem at this location. There's almost zero moment here closer to at the bottom here. It's always not there. It's very, very minimal. You can try and see. So it tend to come in here and start spreading, then the whole thing start moving up. So it tend to open. Because there is force in this direction, in the traffic movement, and also trying to get the thing outward. So that is why you are reinforcement. So it is very important, ladies and gentlemen, that the corner here, this part here, the wing wall abutment joint, you spend some time. If your junior engineer has done the design and you want to do checks, these are area you pick some of this area, look at the detailing aspect, look at the model, the loading and other things, but spend time. You know, a poor design, if it is well detailed, it will never fail. But I'm not saying you should do a poor design. That's normally what they say. And it's a principle with earthquake, that in most of these earthquake-prone areas, if you do very good detailing, and you know what it is, and there's continuity that creates that flexibility, ductility to the structure, it will always survive earthquake to some magnitude. But if you just do a normal detailing, and you have done very good design, but you are not doing it exactly in the area which you are supposed to do, definitely you get in trouble. So that is what we need. It's a very interesting model for abutment. But I advise that if you have any model, but it's not on the Midas that will do for you. All the softwares do have capability of coming with the model, and you are able to look at structure, holistically. You see, we have studied this thing, but if we remain with this mentality of a strip for the slab, you pick a strip, for the wall, you pick a strip, you will not understand how structures work. You will not. Some of these areas you can put BRC, structural BRC, and it will work, so long as it takes care of vertical load to avoid crashing and deformation kind of buckling. It's very, very important. So, but of course we don't encourage people to do it, because now you also look at if it is exposed to corrosion and you are using a smaller bar on a 1 millimeter reduction, definitely the section area is affected and the whole thing becomes a mess. So let's not do that, but it's important. You can take note. This is the pattern of abutment. Now you can actually see, if we pick the middle, this middle portion, and you say I've designed an abutment, you load it. Look at here, these edges here where you have a link or connection with the wing wall. What happened? you can now see that actual reinforcement pattern is not vertical. It is more radial or transverse that may take more reinforcement than, even when you look at the pattern here, this is 2,400, and this is, it drops to 150 to 100, and then comes the mid area or mid span of this mid section of this abutment actually has nothing in terms of moment. You see now by contour it is radiating outward to the red zone. You have the blue, this color, the green, then the yellow. Even from the way you look at the risk analysis or risk management, definitely you will now know that, hey, what are you may find this guy has Y25 in the middle and then 16 at the corner. You say no. This one here we have to be very careful. So basically, I think, ladies and gentlemen, let us try to do. Even if you are very busy, it's important, let's try to do this thing so that if your design gets to someone else, then people, it's easily appreciated and also easy to look at it and get everybody on board. But this thing of only one now, if you have to, by difference from the university, we take vertical. Now, if you do the whole 3D, and now it is horizontal, then you realize that the structure is in a mess. Though, of course, structure will behave the way it is designed and constructed. But you cannot comment on such structure from your engineering standpoint. You cannot go and evaluate and come up with your forensic audit that this is, you have to know that the whole pattern, you have to redesign it based on now what? The pattern and the arrangement or reinforcement there. So this is a very interesting, when I was looking through this, I said, let me share this with my colleagues. And then it's a very important thing. Then this is now the site of the wing wall, applied moment with maximum in red, reducing through yellow to green color. You see exactly. So you can look at it, the pattern, everything, what's happening. I tell you that you can see there's no red at the corner here, it's only 204. Then it starts increasing up here, then also increases this side. This is 308 now. So for a cantilever, you pick one here, single line up. When you come, the whole thing is different. Then you can now begin to see, it's a bit very interesting that this thing require a bit of an approach that look at it in a perspective kind of. Okay, good. This was the drawing. Definitely, we also need to be mindful of shear links. Most of these structures, the detailing should be there. I always see we tend to only give the outline reinforcement, the near face, which is at the retain, and the far face, the water side, then the top and bottom, and the distribution bars, and the stools or the chairs. Forgetting that actually you need, at construction stage, we also need to take note of pressure built up for most of this structure with a bit of thicker section. So this wall clip or the shear reinforcement, always I've seen the Japanese and the Korean in their detailing, they really make everything there on paper, and this is where it's supposed to be. That in a way also controls quality and enforcement on site, and it doesn't bring a lot of problem to project managers. And normally I like saying the dilemma of a project manager, or the dilemma of a site engineer, or the dilemma of a foreman, or the dilemma of a steel bender. He has to begin thinking for the engineer, the designer, what should we do? This gap is too much. Then you start looking at reinforcement. You begin to tell the employer or your immediate supervisor, I need more bars. Then they begin to saying, why are you asking this? People start putting question mark, and then you look. things start coming up, suspicions start coming up. And that is a small mistake done from a design office somewhere, quite miles away or many years ago, if this design project that we implement after 2, 3, 4 years. So when people begin to create, doubts start coming in, you will always not know, and these are the essence, these are the genesis of where things happen. So it's very important that that a technician can also improve project management from where he is. The quality assurance engineer has the whole say now. He's the person who should always make sure that the model, the concept, the design, the model, the output is exactly what is really transferred onto the paper. And it's also important that normally I say you design for construct also and also for maintenance. You also look at maintenance regime, inspection, access to inspection, and the rest of it. So you have to look at it and make sure everything is done from. Now, we normally have this mentality of saying, it's okay, let's just give this outline design. We can do it at construction stage. A contractor can handle that, we review. Risk has started. Risk start building up. Risk that you were supposed to have captured at your design stage, you have transferred it now. That risk is very slippery. You will not get, it will end up with cost overrun and time. Very, very important. So, this is a bridge. And I know they did site layout properly, fabricated the girders, took the girder, used the crane, put them up. I think what we'll do is, I have that model somewhere. I will try to look at that construction staging, then I will share. Just for record purpose. Some of the things we do help us in future. You can still look check around and find that the thing is here, and help you to modify a few things. So my colleagues in the industry, especially the youngsters, please take note that to have one design implemented, it requires not less than 2 or 3 people. You need the entire team. You need the entire team. I always look at role player, and then the activity sequencing, and then the data flow in. Which data must come in, which one should come out of what, who does what when. So it is very important. You start from the bridge architects, the bridge engineer, the designer, the hydrologist, the highway guy, the environmental people. Very, very important. Environment, because of construction in freshwater bodies, especially for us who handle river bridges. It is very, very detrimental to environment, especially even diversions. So we need to be very careful. In the central region and south, where they have 2 seasons of rain, we normally have that problem. How to construct? People tend to fill the river with imported contaminated foreign material, put in water there for some time, construct, remove. Some are not, they are not removed well. It's also not, so it contaminates the water body. So that's how this extraction permit need to be done. If you are working in the sensitive area like the park, where people, the wildlife authority come in, the NEMA people come in. So sometimes when we pass our exams, when we come out, you think when you become a bigger person somewhere, you do it alone. No. You should be encouraged that there's a lot, but you should identify the right team who will give you the right information. For bridges, key will be hydrologists, will be the highway guy and the geotechnical person. Very, very important that those give you the right information. So that's okay. That is something I decided to share with you now, and you can expand more on that, and if there's any query, we shall share. Otherwise, I wish you a good afternoon. Thank you for following and taking few lessons. Bye.